Now problem set 2.1. The problem is two horses pulling a boat which is moving uniformly, and it is from your engineering mechanics McGraw Hill publication by S. Timoshenko, D.H. Young, J.V. Rao and Sukumar Patil. Let us go to the problem. In your book you will not find a diagram like this, but it is the ray diagram. What it is, a boat is moved uniformly along a canal, and this is a boat. This is moving uniformly along a canal. The canal is not shown here, by two horses pulling with forces 890 Newton P, and Q is equal to 1068 Newton. A horse is pulling to this side with a force P whose value is 890 Newton. Another horse is pulling to this side with a force 1068 Newton. Alright, so why I have represented this with a longer arrow? Because this value is more than this value, so this is represented with a shorter arrow, this is with a longer arrow, to just explain the magnitude of it. Acting under an angle alpha is equal to 60 degree. The angle between this force and this force, that is this angle, is given as a 60 degree. And determine the magnitude of the resultant pull. Means this force and this force combined together, what resultant force they will produce. This is the resultant force, the combined effect of these two, P and Q, put together on the boat. And the angle beta and gamma as shown in the figure. This is given as beta, this is given as alpha. We have to find this angle and this angle, right? Okay, this is a very simple problem. If you are pursuing your engineering program in some of the engineering colleges in India or abroad, this may not be asked because this is a school level problem. As we go further into problems, higher order problems numbers, then we will get good problems. Come across good problems that are likely to come in your engineering semester examination. Okay, let us go to the solution. In your high school physics, you have learned R is equal to P square plus Q square plus 2PQ cos theta square root of that. What do you mean by that? Suppose an object is here. The object is pulled to this side with a force P amount of force, and simultaneously the same object is pulled to this side with Q amount of force. And you will find the object neither moves this way nor moves along this way. Then which direction it moves? By taking this side and this side as the two adjacent sides of a parallelogram. If you construct a parallelogram where this is one side and this is the adjacent side, then the diagonal passing through this point is the resultant. Means this one is the combined effect of this force P and Q put together, right? Now, so you can use this formula to solve it simply. So this is your this value, that is 1068. This is your 890. Angle here is given as 60 degree, so this is theta. So we will use this expression. For P we shall use 1068, for Q we shall use 890, and for theta we shall use 60 degree. So putting these values on, this comes out to be 1698.011 Newton. You can put it straight in a scientific calculator. If you can download it from Google Play Store. No need to count it, calculate it this individually, then add to this individually, then do this calculation, then take the square root. In a single line you can find it out. Now let me remind you an important point here. Now look, suppose this part is finished. We'll find alpha and beta, but let me remind you an important point here. What the point is, suppose this is P amount of force, this is Q amount of force. As you can see, angle between them is theta. As I explained, taking this and this as the two adjacent sides of a parallelogram. If you construct a parallelogram, this diagonal gives you the resultant, right? The angle between this and this is theta. Now look, and the value of r is given as p square plus q square to pq cos theta, square root of that. That is what you studied in your high school. Now let me take this p along this direction, means in the direction of q, and take q in the direction of p. Take q in the direction of p. Now if I construct a parallelogram with this and this as the two adjacent sides, then this is the resultant. Now look, what has changed here. Theta remains same, the value of p remains same, the value of q also remains same. So the value of r, this value, the magnitude of r remains same. But look, the direction of r has changed. The direction of this r is not same thing as this r. So remember, if you interchange the directions, the magnitude of r remains same, but the direction changes. Then coming back to how to find this alpha and beta, let me explain you here. Now this is your p amount of force, this is your q amount of force, this angle is theta, and this resultant combined effect of p and q is making alpha with this. From here I drop a perpendicular. Now in this triangle, your cos theta will be equal to AD over AC, that is AD over AC is same thing as OB, whose value is Q. So cross multiplying, your AD is equal to Q cos theta. Similarly, if you take sin theta and cross multiply, you get CD is equal to Q sin theta. So these two things I will be using here to find this angle alpha. Now look, tan of this angle, tan alpha is equal to CD over OD. CD over OD, CD remains as same. OD is same thing as OA plus AD, OA plus AD. For CD, which I just calculated, is Q sin theta over OA. From O to A is P amount of force, so write it as P. AD I just calculated is Q cos theta, so I put it here. Now compare with the boat diagram. That is interesting. Now look, in the boat diagram, this alpha is comparable with this alpha. So straight away use this formula. So tan alpha is equal to Q times sin theta. If you compare this diagram with this, then this is same thing as this. This is same thing as your Q, right? So applying 890 sin 60 over P, that is this value, plus Q, that is this value. Look, this I have taken as Q while explaining this I have taken Q, this I have taken P. So you have to change the modification. So 890 sin 60 over on this. So alpha is equal to tan inverse of this. This comes out to be 26.995, that is nearly 27 degree. And since the full angle, so this alpha is equal to 27 degree. Now this whole is 60, it is given. So is equal to beta is equal to 60 minus 27. So beta is equal to 60 minus 27, that is 33 degree. Now let me one more nice point to clear. When you say Newton is a force, normally it comes to your mind as if it is a big force, is a large force, but it's not really so. Is 1 Newton a big force? No, it's not very big, no. For example, your cell phone, your mobile phone roughly around weighs 150 gram. So I convert it to kilogram by dividing 1000, and its weight due to Earth's pull is mg. G I have taken 10, this comes out to be 1.5 Newton. Means if you are holding your cell phone in your hand, in your palm, or it is kept in your pocket, it is applying a downward force of 1.5 Newton. It's a small force. Weight of a cell phone, an average cell phone, is 1.5 Newton. So Newton is a small force.